Alrighty, happy Tuesday. Thank you to one of your classmates for remembering to hit the record button because I did not on Zoom because I hate Zoom. Uh, Gives me weird memories of Zoom University, which was a bit of a nightmare. But we survived it. I guess you guys had Zoom high school for a lot of you. So congratulations for making it through. We're here now. Uh, yeah, I remember the record button in OBS because that's what I usually do. And if you make me do something different, I'm just going to forget. So but we finished out our web section here. So lots of fun, tons of really cool things you can do with Python and web and automation. Testing, especially, is really big. That's always a lot of fun with Selenium. And then we're moving on to Python objects and unit testing. So the book only gives us so much here. This is sort of like an intro bit. So I'm going to give you more for it as we get into it here. So if we take a look at their chapter on Python objects, and which we're almost done with the book, by the way. We're getting real close. So we've got this week, we've got next week, we've got spring recess. Pretend like that week doesn't exist. So project we start today, it's still morning, right? I want it to be night, but it's morning. We'll be doing 2 weeks, but if we pretend the week doesn't exist, we're looking at 310 here for that one. So if you want to get it done early, great. If you want to wait till after spring break, great. I don't know why it's called spring because it's definitely not spring, even though it's first week of March. Um, I'd still call it winter break, but that's okay. Um, but then we'll finish that out, and then we'll spend a little bit of time midterm review, midterm exam. Like these are all the basics of Python here. Ideally, we're going to get. I'm sorry. No, we're going to talk about it today. Yep. Yeah. So I wanted to use Python objects in classes. So didn't want to start it on Thursday. And hopefully Thursday, I got to double check with our librarian. She'll be able to come and show you a database. We're going to try something fun. I've never tried it before, so we'll see how it goes. Using that database to reach out and contact some people. And then hopefully that'll help us with our Python libraries section. We'll see what's hot, what's popular. Ask a couple of people actually in the industry, see how well that goes. And then work on the group project. So we're getting pretty close here. I think we can do one last one, probably not quite so large, but just playing with some data visualization here, which will be fun for our last individual project. Midterm's easy, I promise. It's just a checkpoint here. It's not timed. We'll start it on Thursday the 19th. Although someone told me I had my dates wrong, and I probably did screw that up because I thought they should be the same numbers here. That's probably not actually the 19th, is it? Let's see. Yeah, yeah. Okay. How did I get that off by one? I'll fix those dates here for you. Yeah, they should be the same as these ones here because March just repeats. But I'll fix those. But anyway, on Thursday, the midterm will open. It's open book, open notes, not open neighbor, right? Just it's your own individual effort. As long as you get it in by the following Tuesday, we're good. So take your time on it, whatever. Read it, sleep on it, come back to it. Not too big of a deal here. Um, and I'll give you a sample one that we can review. I'll have that for you this week, and then Tuesday we'll go over the answers to it, take any questions for midterm review, any last little bit of catch up we have to do. So ideally, this is a relatively light week because you'll still have a project you're working on here. Um, but that's good. I always want to be working on something. Great. And then we'll start the final project. That's, again, the bulk of your score. Should be fun. We'll do this one in groups. And then on our midterm exam slot, which is my birthday, at 8 in the morning, we have to start. Goodness, that is way too early in the morning. Bless you. We'll show up really bright and early. I'll have lots of coffee. And you'll present your projects. It should be a lot of fun. So that's the plan. Believe it or not, we are halfway through now, right? So pretty cool. Hopefully your winter semester is going well. All right, so let's take a quick look at classes here. So object-oriented programming should be very familiar. You all got through your first two classes here. The concepts here aren't really going to be anything new. Okay, we're looking at how we do this in Python. So again, the idea with classes is not that you can do things that you couldn't do without them. You don't need classes for any of this stuff. But what it lets us do is put concepts into code. Because we like classes, we like our nouns and verbs. It's very familiar and comfortable for people, right? When I say chair, you probably think of a chair in your head. So if we write a class that represents chair, you understand that that's just a blueprint for any specific chair. And then when you make a particular instance of that class, then you give it all the details. Oh, that one's blue. The seat folds. It has an armrest. This chair over here has wheels on it, right? It has different attributes, these sorts of things. So we're just allowing us to group these things together. Right? We got all of our fun buzzwords here, your technical ones. We're encapsulating all the details of our class into one nice, neat little package, right? And then we can deal with it abstractly, with abstraction. You don't need to know any of the details of how it works, right? When you looked at the standard template library in C++, we did spend a lot of time looking at some of those basic data structures, but you don't need to know how a vector works. You just need to know that you can push back. In Python, you just need to know you can append to a list. It does it somehow, right? The abstract piece of that is here's the public functions, have them. All that inner workings, all the details we're going to hide away. So we're going to encapsulate all the details of a nice package, give you that nice public interface, the API to work with. It doesn't have to be a web API, right? This is just our class function list or public function list. And then Python is really fun with polymorphism. We don't have to do any sort of pointer nonsense to make all that work, right? Because we don't deal with pointers, right? It just makes life so much easier for us. But I can treat subclasses as their parent class type. I mean, Python's real flexible anyway, but if we override behaviors, it just works for us, right? We get that really cool, that at runtime, we get the correct function being called, which is fantastic. And then inheritance and polymorphism. So we get all of our basics here. Python is a little bit different here in that we don't have the concept of private attributes. Right? Python is what we'll call trusty. It's going to assume you're going to do the right thing, and if you don't do the right thing, well, you voided your warranty. Right? If you open up your phone, your warranty is void and null. Here, yeah.
So these are like structs and classes.
No, they're classes, but there's no ability to make things private in Python. No access control. So we've got conventions that will follow here, but you can get around them. Because I believe in structs you can make things private in C++, not in C. I was actually reading about that last night because I don't know how I got down that rabbit hole. So let's write a class here. This is week 7, right? 6? 7. I think it's 7.
I do know that the syntax was where and was for the name of it.
Yeah, it's got its own syntax. It's not too bad. So we'll wrap it all up with the colon.
When you want to do the methods comes up.
They're just functions inside of a class. All right. Should we do chair? Everyone's excited for chair, right? That one's kind of boring. What should we do instead? Table? Boat? I like boat. Let's do boat. Okay, so let's have a class for boat here. Now, fair warning, I know absolutely zero about boats here. I've only been on a boat like 3 times in my entire life. That includes rowboats. Like I just don't go on boats. So class for boat and then a colon. Everything hangs off of this, right? We use our white space to show it belongs to this, the scope. So everything that's tabbed in now will belong to boat. So what we're going to do is add a special method here. So there's all these double underscore methods. These are very special, fancy methods here. There's a bunch of things here, right? There's a lot of fun things you can do. We're not going to do most of them, but they exist. So the one we want here is init. So init is the constructor. This is the initialize function or constructor. Okay? And then if you want instance functions that operate on a specific instance, so member functions or non-static, you use self. So self is like your this pointer here, if that's helpful to think about. Like a this pointer for all you C++ folks. So it does not like that. That's okay. So in the init function here, the constructor's job is to give values to all of your attributes here. So if it's an instance attribute, you have to say it belongs to self because it belongs to that particular instance here. So I'm going to say self dot, I don't know, color is just blank for now. We're just going to give it a value, right? Your constructor's job is to give values to attributes. Just default values are fine if that's what you have. Self dot, I don't know, do you have makes and models of boats? Self dot model, self dot size, sure. Is that like a number of centimeters? Like a length? I don't know what size would be.
I guess it would be like the width, maybe.
Okay, length or width. All right, so that's probably numeric then. That's probably enough for now. We can come up with more things later here as we go. Um, so this sets all of the attributes here. So now every instance of boat that I create will have its own set of color, make, model, and length, right? So we don't define them here up above. If you try and define something here, like width is 0, now you have a static value. Right? This only exists at the definition of boat here, not every instance of boat. Right? This becomes static, which is fine. You can do things with static values here. Just generally, we're going to frown upon that and avoid it here. It gives rise to all sorts of weird anti-patterns and just bad habits of things if you use lots of static stuff, which is there's good uses for them, but rarely. So ideally, we just don't deal with those here. But so everything you define in a init then becomes an instance attribute of that class. So I can make some boats here. So boat equals boat, and then given the set of parentheses here. So this implicitly calls init here. Implicitly calls init. Oh, look, I spelled it right. I didn't think that would happen. Here. And then another boat equals boat. And then to go change these things, these are all essentially public at the moment here. Right? So I can say boat dot, and I see, hey, make, model, color. I see width, which is weird, but it's static. That's okay. And I see length. Right? So I can't tell the difference between the static and instance values right now, which is also a little weird. Right? So you got to be a little careful here. But let's go, I don't know, let's set the width at 10, and then we'll say another boat dot width. We'll set the 20, and then boat dot color. What's a good color for a boat? White. Okay. And another boat. Okay, we'll make that one blue. Color. Blue. Sure. And I'm going to run this in debug mode, and we're going to look at the values here. And again, we could print them all out here, but that's a lot of printing here. So we just run in the debug mode. I can see here's boat, and here's another boat. Hey, this is a boat object at, pretty sure this is a memory address. Here's another boat object. Pretty sure that's another memory address stored somewhere in memory, right? And then we can expand those out. Sorry, this one doesn't zoom very well. And we can see our values here. So we've got color, length, model, width, color, length, model, width here. That one didn't change. Wow, it's not doing what I expected. That's okay. We can see now we're setting our values here. Oh, okay, it ended. I was going to show you it changed white and blue, but that's okay. So you can see you set all these values, right? So every time you create a boat, you get another set of values in here. All right. So if you don't want things to be public, because we've drilled it into you that that's a bad habit, bad practice, don't make public attributes, right? You should have public functions that modify private attributes. Right? We did plenty of that here. We can do that. So there's a convention to make things private here. It doesn't actually make them private, but by convention, if you put an underscore in here, starting variable, self variable, underscore indicates private. Okay, so if we, oh goodness, let's scroll this down here. Add a bunch of underscores here for these. We'll do width too. I don't know what happened with width. We'll figure this out here. Now when I go to boat here, right, I can't go change these values, but let's go show you. Okay, so boat dot, and I get nothing. So in my IntelliSense tool, by indicating that it's private with an underscore, if we follow the convention, they're hidden. Doesn't mean they're not accessible, but they're just hidden from IntelliSense because that's the convention. I still can say dot width equals 10, right? And dot width is 20, and dot underscore color. But if you're going and accessing private attributes, right, you're voiding your warranty. So when we write a Python class and you have private attributes, the understanding is people won't go touch them. And if they do, then your class is not guaranteed to behave the way it's supposed to behave anymore, right? If you go directly modify these things here. So it should tell us, hey, we're accessing some private attributes here. Well, it's not usually we get a warning.
Technically you should have did or instead of did.
Yep, that's the next thing. So we got to add some functions. So if they're private attributes, we need to give someone a public way of accessing them. Our getter and setters, accessor and mutators, I don't know, whatever you like to call these things here, and we can write them. So to add regular functions, right, we're going to say, hey, I want to define a get color function here. Self, we always need so that it operates on that instance here. We just return self.color. Right, that one's pretty boring. And then define set color. Take self, and then the second argument here can be the color. And I can say self.color equals the color. Right? So my instance attribute equals the argument here. That one's nice. Right? I've got self.this, and they're not going to do the shadowing thing here because this has an underscore in the name, which is handy. So we can set and get color. We can add that for the rest of them here. That's kind of boring to write. Yeah.
So you don't always need the underscores.
Only when you're talking about the self attribute here. I don't need an underscore in the argument here. That doesn't make any difference.
The define, like how init has the.
Oh, that's because it's special. The double underscore means this is a special method. Yep, or a special function. So this is just a regular get color, whatever here. So I could say, instead of color this way, I could say set color, and I could give it blue as an argument here. Now, you don't have to give it self, right? Self is actually implied by operating on an instance here. You can do some weird things, and I'm pretty sure it works. You can say boat.setColor given another boat, and then orange or something. This is really just weird looking here. Weird. Okay. But I believe that works for our boat here. Let me double check. So we can print another boat.getColor. Let's see if we get orange. It works. So because the function is defined at the class level, it exists at the class level. So if you want to call it and give it an instance, this pointer essentially, right? Hey, operate on this instance and this color, you can. But this is a lot of obnoxious typing versus just saying, hey, this instance, call the setColor function. And then the self is implicitly passed as the first argument here. So sort of. It's not actually static, but like it's defined in boat, and then it operates on whatever you're calling it on here. So it has access to whatever instance you give it, or whatever instance you put a dot next to. Yeah.
So for the setters, you would need the self, like when you're declaring it, you would need the self.
Yeah, and then the argument you want to use. So we're always passing self if you want it to operate on these instance values here. If you don't pass self, it has no access to any of its attributes here. Right? So if you just have like a function like define go, I don't know, what did you call it? Drive? You can drive a boat, and you just, I don't know, we'll print I don't know, what does a motor sound like? I don't know how to do that in English. Right. Sure. It just prints burr. This one's lame. But it's telling us, hey, method drive may be static. You're not using self, so why bother? Right? You could take it out if you're not using it here. So it's just giving you a little hint here. But yeah, it's doing that. So let's more actions, make it static, and it just removes that. Now it adds this silly annotation here, which is fine. So this is indicating, hey, this is a static method. Yay, it's exciting. So you might see that some places here. So every boat then can still just go drive, right? So we can call another boat.drive, and it just shows up in our function list, right? This boat can drive, right? So we can do these things here. We got some fun with them. All right, so that's our basic class here. Let's see, what else are we missing? Python objects. Yeah, that's all fine. Classes, types. Yeah, so you can check what the type is. So this is fun. You can see, and we'll get back out the definition of it. as we go. So there's a couple of these built-in things. So if you want to print the type of another boat here, it says, hey, I'm a class under main under dot boat here. This main thing kind of got generated because we're not in a module. A module is just another file in Python. So you can throw as many classes as you want into one file here, or you can start putting them into packages or modules. Modules is just a fancy word for another file here. So we go and import stuff. Maybe we said, hey, I want to import random. Did we look at where that random file was? Did we do that one yet? Oh, that was fun. Okay, so we can go look at that one here. So it's somewhere in, it's not there though. Where's my base Python install? Where's my, somewhere in here. I've got a base Python install I want. Don't want any of those ones. Default. Just want to see where my Python's installed. Hang on. Settings. It's in here somewhere. Interpreter. Interpreter. There we go. So Python's installed to this location. Right? This because I installed it way back the first week here. So it's in C users, Eric C, app data, local programs, Python, Python 3.12. So I want to go find that folder here in a second. So that's C use. I wish I could copy paste, but I can't. That's fine. C users, Eric, app data, and then was it local and programs, Python 3.12. All right. So this is where Python's installed for me. Probably somewhere similar for you, but you're not Eric C. Right? So in here you've got the lib here, the library of all the base Python stuff here. So we go in here, we can find random.py. This is the random module here. So when we import random, it goes out and imports this file. Right? And we can open it up. It's very exciting stuff. I think we can open it. Where's my double click? Oh, because I have that prompt open here. Here it is. So here's the random py. Notice it's got really pretty Python documentation. I basically skip over this stuff because I figure if you know how to program, you can understand documentation. That hopefully is a good assumption here. And it gives you a nice little pop-up here. So here's all the things it does here. So what we use like rand int, right? Rand int. So rand int from A to B. Remember when we use rand int, we get this little pop-up here. The Python doc comment here is the pop-up. If you had a Python doc comment, it will show up in IntelliSense. If you're building a library, please do it. Super helpful. If you're writing code for yourself, it's a big waste of time. That's all. I mean, comments are very important. You should always use them. Always. And okay. But okay, well, it does random range A to B plus 1. So we could have just been using random range the whole time and have random work like every other language where you don't get the endpoint. They decided random should include the endpoint. I don't know why, but sure, it does rand range. And here's the rand range function. Look at this. Right, so for random range from start, stop is optional. Step starts off at 1 here. Does your random range. It's a bit messy to make it fast. Common case while still doing adequate error checking. Sure. iStart is index of start. If stop is none, you don't check for step. If step is not 1, then check for start, and then a random below. Hmm?
Oh, I was wondering why you said 118 and then like the line numbers have 300.
Oh, so I'm inside of the random class right now, so it's showing me, hey, here's the top of this
Yeah,
grouping here.
Yeah.
Yep. So then it throws the top of that function here. Yeah.
So what's that reference about random inside the declaration up there?
It's a great question. So that's up to 110. So random is somewhere in here, looks like. We imported another random function. I don't Module implements the Marcin Twister random number generator. That means a whole lot of things to me. Okay, so we use this. Must be a good thing here. You can find, look, it even has a link to _random on pythondocs.org. How cool is that? So you can go look it up. Fun stuff. Anyway, that whole rabbit trail was because that's a module. So if you want to write your own module, if you are the sort of neat and tidy person who likes to have classes in their own files, I like that. We can go add our own classes. We can go add our own files. So in our project up here, right, here's the folder. I'm going to right click and say, hey, I want a new Python file. We'll call this boat. Actually, that should be lowercase b boat. Sorry, we rename that. Doesn't actually matter, but module names are usually lowercase here, and the module is the name of the file here. I'm going to take boat here, and let's go and take boat, drop the boat over here. So now we have a boat class in a boat module. So if I want to use boat, I can say, hey, I want to import lowercase b boat because that's the name of the file. Right? Now it's upset because it doesn't know what a boat is. Well, the boat class isn't defined here. It's defined in boat.boat. Because boat is the module, this is a class. Because you can have more than one class in a given module here. Now, the lowercase b boat here is probably a bad idea. So I'm going to do, this will be some boat here. Because I don't want to clobber the name of my module. That'll get things a little confused. Boat. And then those ones, okay. And then we need boat.boat over here. Boat.boat. So module.class here. That's the module or file name. And if you're tired of typing all of this out here, yes, there is an easier way. Thanks for asking. Like, why would we have to type boat.boat every time? We could say from boat import capital B boat. Then, if you have that notation, you don't need the module prefix because you said, hey, I specifically want this class out of this module here. And then you can just use the class name. Right? So this is imports specific class from module. Okay. We got boat.boat, both ways work here as we're going. But now when I run what is type here, remember this we all got here from type, bless you. Now the type is boat.boat. Here's the module, here's the class. We don't have that under main thing anymore. So the convention in Python is whatever file you hit the run button on, whatever file you're telling Python to go and execute, is known as the main module, under main. Doesn't matter what its actual name is, it's known as under main. So you can do these weird things in here. If you want to put code in your boat module, you can here. Print I from boat module. Module. Please don't put code here in modules. Now what happens, I'm going to run main, and when I get to the import, it runs it. So what import does, it's essentially copy pasting that contents into that line. So when we're importing, it goes and grabs everything in that file and puts it in that one line. If there's commands, it executes them. So it's not what we want most of the time. Right? Maybe you just put something in here to test your boat stuff, but now it's running here. So a workaround you can do, if you like having code in your modules, which again, don't, but that's okay. If you like it, you can. You can say if name is under main. That's got to be in quotes here, right? I think. And that's under name. Under name. Under. Is that it? Yep. Now I can print hi from boat module. Module in main check here. And I'm going to take that one out here. Nope. If name equals main, sorry, equals main, not is. If I run my project here, so when I hit run, it's still running the main file. It didn't run the boat file, right? That was set to run main up here. I don't know if you've noticed that before. You've never had to deal with multiple files, so it probably never mattered. But when I hit run, it says, okay, let's run main. I don't get that anymore. I'm still importing boat, but it's not running. If I come over here and I right click and say I want to run boat, now I get the code here. So whatever file you tell Python to run, its name is main. That's the main file. That's why we got the main.boat when we looked at the type, because it was defined in the main module. This is the one that Python started with here. So this essentially allows you to have code that only runs if you run the file, a specific module file. Okay, so some people really like this, go for it. If you want to put some code in there, but you don't want it to run when it's imported, put it here and hide it with an if name is main or equals main.
So basically, does that run when it gets imported?
So it won't run when it's imported because when you import it, the name is boat because we're importing it by module. Only when you tell Python, hey, Python, run this, interpret this Python file, is name overridden to be main. So the file that you run in Python is known as main here. Everything else keeps its module names when you import them here. So it's a way to kind of like hide a little bit of execution here if you want. And some people really like lots of modules and they like putting code in there, so go for it. Okay. All right, the next piece we're going to look at here is inheritance. So let's make another module. You don't have to have a module, right? You can put all your classes in one. I started programming a long time ago when I seriously got into it. I started learning Java, and with Java, you have to have one file per class, and I've just stuck with it. But I also think it makes your source control look a whole lot nicer because you get to see when that particular class changed, not when any one of the 30 classes in a giant module file changed. I just like the history look better. Again, that's just a preference. Doesn't really matter here.
Of course, they told us to do that. Whatever class in its own file.
Yeah, you could have your separate header files and implementation files, and I like one class per file. You don't have to. Again, it's just a preference here. And when you go out and get a job, just do what they tell you, right? Because it doesn't actually really matter, right? And as long as everyone does the same thing, you know what to expect. So conventions are very helpful. Now let's make another kind of boat here. How about we call this one a rowboat here? Oh, I'm sorry, that should be lowercase. So this will be row boat. You thinking like cruise ships? You guys gonna go out somewhere fun and like actually see the sun for spring break? I don't really like big boats. Okay, I'm okay with big boats. I don't like big water. I think is more my problem here. Don't really want to be in the middle of the ocean. Doesn't sound like fun. What?
Is that why you've only been on 3 boats?
Probably. Yeah. I mean, I don't even like small boats really, but I just don't really like lakes. I went to Hawaii once as a kid because my orchestra had a competition, which I'm pretty sure they put competitions in really nice places so people can go to really nice places. Like, there's no competition in the middle of Idaho, right? The international competition was Hawaii. We went there. I swam in the ocean once and it was nasty. Don't like salt water. So I spent most of my time in the pool. And everyone laughed. Like, why would you spend your time in the pool? Because salt water's gross. It's just not fun. But anyway, no fun with oceans. So if I want to use inheritance, I need to know about boat. So I'm going to import boat. So we're going to import or from boat, import boat here. So I've got the boat class now, right? And all of this is based on relative paths right now. It's in the same folder, so I can import it by name. I don't have to go tell it anything else. Python's going to go look for stuff in your folder and stuff in the Python library. If you put it in a weird spot, weird stuff happens. Don't worry too much about it. All right, so we're going to import a boat. So I'm going to say, hey, this is my class for rowboat now. And then in parentheses, I'm going to say boat. So this is indicating inheritance. So whatever's in parentheses is inherited from.
That was
Yep. So we're going to inherit from boat. So we are do all the things that boat does here. So if we just have now, I don't know, what do we want? A drive should be something different then, right? We want to print row your boat. When you drive a rowboat, you row your boat. You don't brrr, right? This is a rowboat. And you notice there's a cute little override note here, a little icon saying, hey, you've overridden the method in boat here. Just an icon to let us know we did it here. And then back in main, if we want to go import rowboats here, so from rowboat, import rowboat, here we can make a rowboat. Let's do a rowboat, small rowboat, rowboat equals rowboat, set of parentheses, and then we can call small rowboat dot drive, there we go. And when we run our main, oh, I'm running boat here. I got to go back and pick main. Now when I run main, we get row your boat. What you'd expect to have happen here, right? Now, there's not really a way to make this be all that polymorphic here because Python doesn't enforce types. Right? We're typeless. So I'm not saying, hey, I want a list of boat here. You just have a list. And if you put a bunch of boats in there and you call drive on them, you'll get the right one here. Right? So I can just have a list of these boats, and when I call drive, I'm not actually treating it as its parent class at all. Because we don't force things into types for us here. But we can inherit. Okay? Now, rowboat then, small rowboat, dot gets all the other stuff, right? If you inherit from another class, you get all of its attributes, you get all of its functions, right? So I get my set and get color, have all those other attributes here. So if I were to put this in debug mode and look at it here, I can see my small rowboat. What? Oh my goodness. No, just keep on going. Invalid syntax? Oh my god, I didn't finish my line here. What's going on here? There we go. So we need that one. We'll continue on. All right. So my small rowboat then. Here. Small rowboat has, oh look, they're protected attributes. It's just letting us know, hey, it's got some attributes here that are protected. Now I've got color, length, make, model, width here. Right. And I've got my sum boat. I've got my color, make, model, length, width here. I've got my other boat, right? So you can see it has all the attributes of boat because we've inherited from it. Right? We didn't call our init method though, right? So what if the boat class wanted something passed in here? You can add arguments to your init method if you want. So maybe we have a make and model here. Maybe a length too, right? If most boats don't change their size, I think I can say it, right? All you boat folks, is that true? Most boats aren't going to change their length. Okay, so let's pass them as arguments here then. So we'll say, hey, then make is the make, model is the model, and length is the length here. But color, you can paint your boat anytime you want, right? When we think about classes, we think about what should be private, what should be changeable, right? What things are fixed or read-only, right? And what things are changeable here. You aren't going to change the make and model of your boat. You're not going to change the length of your boat, but you can go paint it here. So it makes sense to have a set color. You can go change it here. Maybe we'll add a couple other gets here. So we'll have a get make, return self.make, a get model, returns a self.model, and a get length. Get length, return self.length. Right? So we have get onlys for these because it doesn't make sense to change them. If you don't want that attribute to change, don't let it change. Accept it as an argument in the init in your constructor, and then don't give them set functions. That's how we make them read only. Right? No one else gets to change them. Now I have my make, model, and color here. But now, it's not working here because I need some arguments here. This is main line 6. Okay, so boat here. Well, what are we going to do? We need to tell it then, I don't know, who makes boats? What's a make and model of a boat? What? A liner? Bayliner? And what kind of model is that then? 34, model 34. Okay, great. And this one is, now length, if we don't give you a unit of measure here, is probably pretty bad here. Like, are you going to tell me 5? It's 5 feet long. Are you going to tell me 5? It's 5 meters long. Are you going to tell me it's 500 centimeters long? Are you going to, like, what are we putting in here? This is probably bad here, but we'll just put 5 for now, right? So boat, and really, if we don't care about those things, right? I don't really care what the values are particularly here. We can go do that here. But now we have a problem with rowboat. So I run this one now and I get, oh, rowboat. Rowboat, type error, boat init missing 3 required positional arguments here. I didn't make a rowboat, or I didn't make a boat, I made a rowboat. We've got a problem here. So can we just give it 3? Do you think we need to give it 3? Rowboat, make, model, length. Look at that. We can just give it 3 arguments and it passes it right through boat. How cool is that? So if we don't have a constructor, we're just passing it right to our parent class constructor. It's probably a little bit ugly here. So it's better, but I guess a little bit more typing to add our own init method here. And then it's going to tell us here, oh, you missed a call to your superclass init method here. So if you want to define your own, you need to also go call your superclass one, right? So yeah, we can use the little type in for me here. So it's super parentheses dot init. Super weird looking syntax. I didn't come up with it. Sorry, that's what it is here. And then we give it whatever we want to give it here. So maybe all rowboats we'll just say then are always, 5. We've got options, right? You don't have to have the exact same thing here, right? You can mix and match. You can change them. We can add additional things here. We have like number of oars, I don't know, right? And then you can have a self dot number of oars. Number of oars equals the number of oars here. I mean, some rowboats like have 10 people rowing at a time, right? Those big rowboats. Isn't that an Olympic sport? People row in boats. Why is that an Olympic sport? I'll never know. But sure, some people really like rowing their boats really fast.
It's hard.
I'm sure it is. I don't mean to minimize it, but like, why do we still have 5 people in a boat going really fast as a sport? I don't know. The Olympics don't make a lot of sense to me, but that's okay. And also, why like swimming? You've got so many different events, so that you're pretty much anybody who swims, and if they're really good at it, will have the highest medal count. Doesn't mean they're like a better athlete than the people in other sports. They just don't have a gazillion events, right? Like track and field, we've got a couple, right? But at least they're different distances. But there's not a running backwards track and field event for the 100. There's not a crawling 100 meter. There's not like it feels unfair, right? No, okay. Anyway, our number of oars. So we've got that. So we're going to call our superclass init here and pass these values forward, right? And our list doesn't have to match necessarily. Now this should run here. Oh, we have no oars, and we're a pretty sad rowboat here with no oars. We're not going to go very far in our rowboat here. No, okay, so let's do this. So then we'll say for oar in range, self dot number of oars. We'll row your boat as many oars as we have. How about that? All right. So we'll go fix this. Let's have 2 oars here, and then we'll get double row your boats. Right? Because we got 2 oars. 2 people can row. Or no, 1 person uses 2. Math is hard, and it's still early in the morning. We got classes, we got modules, we've got inheritance, we've got encapsulation, we've got abstraction, we've got sort of polymorphism. It doesn't really do polymorphism. That's okay. Are you okay with the fundamentals here? All right, awesome. So the next thing we want to do, now this one is not very interesting here. Let's add something fun to boat here. Let's add, do boats have motors? Speedboats? Okay, so let's make a class for speedboat then. New speedboat. We should have done underscores here is what I should have done instead of rowboat. That's ugly looking. Let me go rename that one here. Should follow our convention. Rowboat. There we go. And when I do refactor, it changes it everywhere. That's the really nice thing. So you don't have to change it everywhere else. So our speedboat then, we're going to from boat import boat and a class speedboat imports from or inherits from boat. So we'll add our init method here, init, and then we'll add our call to superclass because I don't have to do the typing myself here. So we need all those things. We probably also need an engine size or something here. Engine size. We probably have fuel in liters, and then we probably have a max fuel in liters. We got a bunch of attributes here, right? Those kind of things are kind of important here in our speedboat. So self dot engine size. Engine size is the engine size. Self dot fuel in liters. So I can copy paste here, right? And oops, my spacing. Max fuel. Self dot is the max fuel. Now maybe all new boats start at 0, right? Maybe we don't have to pass that one in here. Right? If you're a brand new boat, you probably don't have any gas in it yet, any fuel in it. I don't know, but your max is probably always the capacity, right? So when you go and drive a speedboat, then we probably need to know how far we're driving, right? Not just that we're driving it, right? Or maybe we just take some gas out here. I don't know. This doesn't have to make a whole lot of sense here. So every time we drive, we'll check, hey, if there's fuel, self.fuel in liters is greater than 1. I don't know. Use a liter to go take your boat out for a spin. Maybe it does. is greater than or equal to 1, we'll print vroom. Right? If you're speedy here, you get more than the burr as we're going here. And then we'll take our self.fuel in liters, subtract 1 from it, because we went 1. Sure. Otherwise, if we don't here, so and this is maybe a little bit backwards here. Maybe we'll go the other direction. We'll say, hey, if my self.fuel in liters is less than 1, we can raise the value error. Say, not enough fuel. That's an exception. Right? Our value error is here. If we don't do that, right? If we don't raise an exception and crash here, then we'll go vroom, right? So we can raise our own exceptions to protect the integrity of our class. When we're encapsulating all of our details here and saying this is what happens here, if there's no fuel, there's no brrr with your boat, right? You're out of fuel, you don't go vroom. You got to pick up those oars. Maybe, hopefully, you're a rowboat as well. Okay. Does that part make sense with our exceptions? We did this before, right? We're just looking at this how we do it in C+ or in Python. Then we can go do these. So we can drive, and then maybe we have a place for add fuel. Add fuel. It takes a fuel in liters here. So we'll take our self.fuel in liters plus the fuel in liters here. Oh, but we don't want to spill gas here. That's real bad, especially in a lake, because then it's real bad for the fish and other wildlife, right? So we should check, hey, if that value, right, is greater than our self.max fuel in liters, let's raise the value error. Too much. Please don't spill, right? Right? No good. Otherwise, then we'll just go and add it here. Plus equals the fuel in liters. Now, you might also want to check, right, because people do the dumbest things here, that it's not negative. If my fuel in liters is less than 0, here's a value error. Just as, as specific as you want to get with these things here. Can't add negative fuel. Please obey physics. Okay? Sure. Whatever you want to do with these here. Right, so now we've got some interactions here. Right? We've hidden away the details of us managing fuel, and the only way that value changes is by drive and add fuel. Right? There's no set function for that here. Probably need a get here. Right? So define a get fuel in liters turns self.fuel in liters. Cool. So we can go get that value back out. Right? Ooh, maybe it should have been based on engine size, how much fuel we used. That's okay. That's too much arithmetic right now. We can add that a note for later. So to do use fuel engine size. That sounds like fun, right? Okay. Okay so far. Oh, why does it have an error here? What? I don't know where it got that line from, but that seems like it didn't need that line. All right, so now we got a speedboat. So now we can go and import our speedboat. Right, so from speedboat, import speedboat. Cool. We can go and use our speedboat. Speedboat, fast boat equals a speedboat, and we have to give it a make. We have to give it a model. We have to give it a length here. I don't know, 10, and then an engine size. I don't know what 1. If that makes any difference here, and 10 for my max fuel in liters here. And then if I go take my fast boat and I drive it here, it's going to crash on me. Not enough fuel, right? We forgot to put fuel in the tank. Okay, so before we drive, we take our fast boat, we have to add fuel, and let's, I don't know, add 1. And I should be able to drive. Then we get vroom. Cool. We can go drive. So, but doing this by hand is really tedious, right? We're essentially testing the code we wrote, right? Seeing, did it do what we expect it to do? That's really slow and tedious, and then I have to look at it, and I have to, see a whole bunch of other stuff here and hopefully find the right thing. And I don't know if you noticed, but I make a lot of mistakes, right? It's kind of human nature to make mistakes, especially if we do the same thing over and over and over and over again, because that's really, really boring. So wouldn't it be nice if we could make someone else test the code for us? Yeah. And you know who's really good at doing the same thing over and over and over and over and over and over and over again? Computers. They're really good at that. So we're going to make the computer test it. Awesome. So we're going to go to Speedboat here. I'm going to right-click on Speedboat and say Go to Test. And it says, you don't have any tests. Do you want new tests? Yes, please, PyCharm. Thank you for making tests for me. And it says, okay, I'm going to make a new file called Test Speedboat. I have a new class name, Test Speedboat. Sure. What do you want to test? Well, I want to test drive. I can't really drive unless I add fuel. It's a little bit silly here, so it's okay. We're going to feel a little bit bad that I didn't test them individually here, but we're making unit tests. I want to test one small unit of code at a time here. We're going to test drive. So from Speedboat, import Speedboat here, so we can go and use Speedboat. I wish it added that line for you. That felt pretty obvious. I don't know why I don't add it, but that's okay. Right? And then what we get here now, when I go and run tests here, I get a really cool test explorer, and I get a failure. Big red X here. You failed. Well, that's okay, because all it did was fail. So what we're going to do is we're going to follow a convention. Again, it's just a very common convention in industry here. It's not required, but it's a nice convention. We're going to arrange, we're going to act, and we're going to assert. This is the AAA convention here. So arrange says we're going to set up our variables for testing. Act says we're going to call the code for testing. And then assert says, did we get what we expected? Okay, so to arrange here, when I'm driving, I need a speedboat, and I know it should use some amount of gas here. So I should have an amount of gas when I'm done that's less than the amount of gas than when I started, right? So I'm going to make a speedboat here, or a fast boat here, equals a speedboat here, and we'll give it make and model, and length here doesn't matter, and engine size doesn't matter, and fuel capacity matters here. Okay, so we got a fuel capacity of 10. Then I'm going to take my fast boat, I'm going to add some fuel here. So if I'm adding 10 to it here, when I drive, I should have one less. So I'm going to have an expected fuel here, which should be 9, right? Okay, now we can call some code. So let's drive the boat. So fastboat.drive, and then we'll have an actual fuel. Here is my fastboat.getFuel, right? So call the code we're testing and get the value, and get values. Then assert. Did it give me what I expect here? So let's check. So we can say self.assert equal here, my expected value and my actual value. Do these things match here? Now I can go and run my tests here, and I get a green check mark. It passed. It did what we expected it to do. It said, okay, you expected to have 9, you actually had 9. Your code seemed to work here. That's pretty cool. So the other thing we should test, I should have tested the add fuel here. Now I feel bad, right? So we're going to define a test add fuel. Now, add fuel has a couple different pieces here in Speedboat, right? There's a way of measuring this. We call it code coverage. How much of your code actually runs when you run your tests? You know, our pie in the sky, unicorns and rainbows world, we'd love to have 100% code coverage. I want every single line of code to run when I'm testing it. And so far, I don't have that because I didn't check if I actually get a value error here. I didn't check if I get a value error here. I haven't tested this. So when my tests run, these don't run. Now, the nice paid version of PyCharm will measure that for you. The free one doesn't do that. That's one of their bells and whistles. So you can actually get that as a metric and see how much of your code is running when you run your tests here. Which, ideally, every bit of code that we write was worth writing, so it's worth testing. Because why would you write code if you don't care if it actually works or not? That just seems stupid, right? If you want me to write it, you want me to make sure it does it. So I want to do a test here. But again, the people that pay us sometimes are like, oh no, that takes too much time, just skip it. You're probably good enough, right? And you're like, well, of course I'm good at my job. They're like, okay, then don't bother testing. And then you just feel bad about yourself. But really good, because then you're awesome, right? You're so good you don't have to test it. It's a silly thing. So we can go and test it here. So for testing adding fuel, we need to test that it doesn't take a negative number and that it doesn't overflow. Right? So actually, I want 2 different tests here. So I'm going to say test fuel can't add negative here. So we're going to go and try doing this thing here, right? So we need a boat, we need some fuel, do these sorts of things here. Now, all I need is the boat here, and I don't even need to see what my expected fuel should be here, right? This gets to be a little bit weird with these ones here if we're looking for an exception here. So when I go and add fuel, if I add more than 10 here, it should raise an exception, right? So there's a right way to do it, and then there's the cheesy way to do it here. We'll do the cheesy way first because it probably makes a little bit more sense. We're going to try boat add fuel, and then we're going to catch a value error. Oh, goodness. Catch value error as exception. Why is it not catch? Does not like that. Why does it not like my line here? No. Try, what is it? What am I missing? Oh, it's not catch. Sorry. It's an accept. There we go. Different word here in Python. My bad. Then we can go and check here. We can say self.cert equal by exception dot, is it here? It's like a message here. I forget. Is it just exception? I don't know. We'll say assert. Just pass. Assert. There's fail. I don't want fail. I want the opposite of fail. Here's my like success. Message is the exception. This was supposed to be the easy way here. I don't want add note. Is it args? Args? No. It's a way to get the message back out here. I don't know. We can see what it is here in a second. Let's print the exception. I don't remember what it is off the top of my head here. Too much don't spill. Okay, so we printed it out here. So sure. So we can say self.assert equal here, the exception, and please don't spill. Is that going to work for us? Probably not. That's okay. Right now it passed. Ah, here we go. So let's get this whole message here because we're just going to cheese it. Nope, that was all in one big string here. Please, oh my goodness. With a escaped apostrophe. Is that? It's so ugly. There we go. Okay, let's try it again. Value error doesn't match. Oh, no parentheses? No, do we want the parentheses? There's another one in here. Another quote and a parenthesis. We're so close. Too much, don't spill. Weird. Don't spill. I just say it as a string here. Expected, actual. What's this one? That's what I put in here.
Oh, it just removes a value here. String, double thing. So it's too
When I converted it to a string, it removed that bit here. Hey, all right. Now we got it. That was really worth it, right? So sort of putting the asserts in here, catching a fail. This is ugly here, but it gets the job done. It's 10:45. Crap. I wanted to talk about the project. It's my fault for being late. You want to move it to Thursday? Okay, we'll talk about it Thursday then. All right. Thanks, folks. You take care.
Wait, not to like you get